Hi, welcome back. Tech and Shashi. Today we are going to present OSI model, Open Systems Interconnection Reference Model. As usual, we are going to look after some standard flow of session. The first thing is the background, purpose of OSI, what makes OSI model, and overview. As part of the what makes OSI, we are going to look after the analogy today. The first thing is about background. Background is on open network architecture. What does it mean is when you say that there are a handful of people, they're coming together and they've been started defining the standard architecture, which is the last session what we looked after is the protocols. Then they're followed by there's a conceptual model. If you look after any OSI model in a physical component, no.
Are you like a crazy person?
We are not kidding. We are not a crazy people, I believe, right? So the conceptual model is about conceptually to understand how the network systems work together and what are the different layers in it. When the layers gets formed, we'll get a gradual understanding when we are going forward. The first thing is multiple vendor interoperability. Sorry, I'm not good at that word pronunciation. I'm an Indian accent. Maybe that could be a reason. Okay, apologies for that. Basically, what does it mean is OSI model can enable that different vendor products can work together. That's the purpose of OSI model. The next thing is about data encryption, data encapsulation. So it wraps the data, which can ensure that the data is being sent to the recipient, not to the other party who is not intended to read the message. Next thing is about OSI model as a blueprint. Since we have a different vendors who can product the computer components or network components such as laptops, computers and printers, routers, Wi-Fi connectors, cable, whatever you call it in a computer world, in a digital world, all of them is manufactured by different vendors. So all those vendors use a OSI model as a blueprint. Hence, that can enable the multi-vendor operability. That's the purpose of the OSI model. Okay, now let's jump into the purpose of OSI. The purpose of OSI, as we talked about in the background statement itself, helps to understand the communication over a network. There are different components involved when you are sending a message from one computer to other computer. If there is any problem comes up, then we can identify the problem, where that the problem is. Is that a part of the application layer, or is part of the data layer, or is it part of the transport layer, where that problem is really. Then it's easy for us, the administrator, to troubleshoot further. So that is the intention behind this layer, right? So the next thing is about troubleshooting is easier by separating functions into different layers. So we group a set of functions or set of operations into one layer. Hence, if there is any problem within that specific group, then directly we can identify that's the layer is a problem. So that's easy. We can narrow down the problem into the specific section, then we can troubleshoot easily. The next thing is about a common platform for software developers and hardware manufacturers. This is what we have discussed in the background statement as well. Now it goes to the dividing large data exchange process in smaller segments. What does it mean is if I'm sending a large file, the large file will not carry to that network as it is. Instead of that, the data is being chunked or framed or bits converted into that small chunks. That's converted into digital signal. Then it's carried on the wired network, carried on the fiber network, physical to physical, computer to computer, host to host communication happen in the electrical signal. The next thing is about analogy. So the analogy starts with, I wanted to make that analogy as the whole purpose of this lecture. When you understand the analogy, then you can fit the same model into that OSI layer or any concept. This is how I wanted to teach it. So when you understand the analogy completely, then we can understand what is that concept we are trying to understand that we can fit together. That is the purpose of it. Okay, let's jump into the analogy. The first thing is the analogy is, let's consider that there are two people, they wanted to communicate each other. They are sitting in a different house, a different country, and the one person does not know English, other person does not know the other person's language. Thank you. So let's consider this context, then we'll move to the analogy. With that consideration, we can get into analogy. The person who wanted to send the letter to other person who hosted in the other country, the person is drafted for 20 pages of letter. So with that, the person written and he wanted to send it to the foreign country. The next thing is, since that understanding purpose, what we assumed is the other person does not know the language. So the second step is we wanted to translate that first person language into that the receiver can understand. understand. Okay? Receiver can read it. That is the second step. That's the second layer we call it. The third step is about we need to write down the sender's address and as well as the receiver's address. This can ensure the intended recipient can receive the letter. It will not go to anybody else, so it has to include the address, name and the location and the pin code. The fourth layer is the separate and number the pages and request another package if one is lost or damaged in an email. So what does it mean is, instead of sending it a whole chunk of message into the one courier, separate that individual pages or couple of pages together and number that the sequence of the sequence of pages, so that it will be easy for the reader to sequentially read that and understand what the sender message is. Then the fifth step is post center sorting letters by zip code. Say example, there was one post center, post office, they used to receive all the mails, and based on that zip code they wanted to segregate it and route them close to the destination. They wanted to separate that based on the zip code, and they wanted to keep that in a separate buckets or separate bucket, and that can be diverted to the destination. The sixth step is local post office determining which vehicles to deliver. For example, so now we have a different buckets with respect to the postcode. Now that person has to decide whether that postcode can be reached by what mode of transport. Is that a plane, or is that a car, or is that a rail or autos? How that is going to be happen? With this one, so with these 7 layers, these 7 steps, we are going to map one to one what is that OSI model is. Okay, let's jump into that OSI model so that we can map that one by one. So first let's start with the overview. All when you say how we are going to remember, since we talking about the 7 layers, right? How we are going to remember this 7 layers for maybe the first time learners, it's maybe difficult for them to keep that in a memory. So that's the reason I wanted to keep a one short form. They can map here as well. For example, all A stands for application, and people, all people, P stands for presentation, and S stands for session, and then T stands for transport, and then need, N stands for network, and the data, D stands for data link, and the P processing stands for physical layer. So this concludes the different 7 layers. So all you need to remember is all people seem to need data processing. Everyone in the world need data processing, right? That's the way we wanted to remember this. All people seem to need data processing. Application, presentation, session, transport, network, data link and physical layer. This is what we are talking about. Okay, let's quickly grab into that. What is that? Every individual layer responsibility. We can map that with the postal analogy, whatever we are looked at it. The first thing is application, where the person wanted to draft a message and send a message to somebody. That's a place where we have file transmission, message exchanges and termination sessions. This is the place where it says that, okay, I want to write something, I want to process something, I want to read something. So that's the place where it starts. The physical computer interact with this application layer. Application doesn't mean that the application itself, it's just a layer. Actual application interacts with this application layer protocols. What are the different protocols we have as part of this application layer protocol, application layer of some OSI model? We have SMTP, FTP, Telnet and LPD. SMTP protocol is the one used for the Outlook and mail, simple mail transfer protocol. And the next one is FTP, file transfer protocol. Within the intra-network, we can transfer the file securely in between the computer systems. That is the FTP. And the next one is Telnet, which is the client-server model. And LPD stands for Line Printer Daemon Protocol, which is the communication between printers and computers. The next thing is about the presentation layer. The presentation layer is the where the place the letter is converted into the language where the recipient can read and understand. That's the presentation layer, which this layer takes care of translation, encryption and compression. Translation, which is the one when you map that into analogy part where that one language translated to other language, and compression and encryption is about reducing the size of that message. Still that original message should not be changed, but that size of that message can be compressed and should be encrypted as well. When you say encrypted, that should not be read by anybody else. Which this layer has the couple of protocol JPEG and GIF. The JPEG is a compression of digital images, but quality of image varies after compression. However, when it go to GIF, which is a compression without compromise with the image, without compromising the image clarity, that is the GIF format. Probably you understand the difference between these two. Mostly the JPEG used in the cameras and GIF used as part of the internet, I believe. And the next thing is about the session, where we have established that when you compare with the analogy, so that's the place where we are ensure the sender and receiver's address is written as part of it, which is the connection management between client and server. The relationship between these two will be established as part of the session layer. This layer we have a different protocols like NFS. NFS stands for Network File System, the client server application that lets computer user view and optionally store and update files on the remote computer as though they were on the user's own computer. The SQL, everybody knew about SQL, which is Server Shared Memory Protocol, is used by clients to connect the SQL server components. And the next one is about NetBios. The NetBios provides a communication services on local networks and the RPC, remote procedure calls. Without knowing the difficulty or the way it's implemented in the network, the one system can make a functional call to the other system, which is the RPC. Probably most of the Java developers more aware of this RPC, since we used to do a lot of JDBC RPC calls to call the other functions, basically other hosted functions. The next thing is about the transport layer, the connection management between computer systems. So this is a place where this transport layer, this fourth layer, the middle layer is going to be the heart of any network OSI model. OSI model is the heart of the OSI model is a transport layer, where that it maintains the a state of that communication between the systems. So that this layer has a TCP, UDP and SPX. When you say TCP is a transmission control protocol, is standard that defines how to establish and maintain a network conversion through which application programs can exchange data. When it comes to UDP is a user datagram protocol, is an alternative communications protocol to transmission control protocol, used primarily for establishing low latency and loss tolerating connections between applications on the internet. SPX. What is that SPX? Most of us may not be aware. Even I was not aware before I was understanding this OSI framework. What is it? OSI stands for a sequenced packet exchange. As we talked about earlier in the analogy, we wanted to keep that small packages, the messages has to be split into that frames. This is a place where it starts it and number that messages. Numbering the sequence of messages, how that's splitted, so that the reader can arrange in the same way, then he can read that whatever that user has sent. Then it comes to the network layer, where the path and logical addressing and IP address assignment is happening on this layer. Anything related to IP address issue or dynamic IP, the IP address is not resolving, then you need to jump onto this network layer where you have IPv4, IPv6 and IPv6 protocols. When we say that IPv4 is the traditional way of using it, and for when it comes to IPv6, which is the successor of that IPv4, and IPv6 is used on the cryptographic security services to project communications. So the next layer is Datalink Layer, where the Datalink Layer has the physical addressing and frames, MAC and L. Probably most of the computer engineers who worked as part of the development for some time, they may be heard about MAC and LLC. The LLC and MAC, what it stands for is, I don't remember that LLC. This is the MAC address, which is the router address basically, and then physical addressing on the frames. Then the protocol is used as part of this layer is to point and as well as the reverse address resolution protocol, which is absolute computer networking protocol used by client computer to request internet protocol basically. This is about where the place it's requesting for the IPv4 addressing. That's the protocol about reverse address resolution communication protocol. The last one is L2F. L2F is a layer 2 forwarding, is a tunneling protocol developed by Cisco systems to establish a virtual networking between the virtual networking connections over the internet. Say probably most of us we are aware that since as part of this lockdown, most of us working from home using a VPN, right? Virtual private network. That's been established. If you are using a Cisco VPN, then that what does it mean is it uses L2F protocol to establish the private network from your office network to your home network. That's the L2F. The last layer is the media signal binary transmission. Physically, how that message is being transferred from one computer to other computer, is that through wire or fiber, or how that message is being transmitted. Until that layer 3 session layer, that's the software is been programmed. Most of that layer until session, there is a software only involved in this OSI layer structure. The transport layer is the heart of that OSI model. When it comes to last three, the bottom three, network, data link, and physical layer, which is hardware plus software. With the hardware the hardware programming, the hardware is being programmed in the form of software so that it can operate, they can interact with the software layers. So the last layer has the RS-232, DSL, and optic fiber. So what are these things converts about us? RS-232 is a standard protocol used for serial communication. So in the sense, like, it's connecting computer and peripheral devices to allow serial data exchange in between them. So it's about computer device with a wire connecting a cable into the computer. That is the RS-232. Then the DSL. The DSL is about a digital subscriber line. What does it mean is originally digital subscriber loop, we call it, is formally a family of technologies that are used to transmit digital data over telephone lines. The last one, optic fiber, which is the high demand when it comes to the high data requirement. Mostly that every individual companies, they used to get their own line of optic fiber from the data center from the ISP provider. That's the place is used for many telecommunication companies to transmit telephone signals, internet communication, and cable television signals due to much lower attenuation and interference. Optical fiber has large advantage over existing copper wire in long distance high demand applications. Okay, we are done with this OSI model. Hopefully this helps you. If not, please comment your questions. I'm happy to answer as much as I can. So as our channel says that we wanted to learn as a team. That is our dream. So even if you guys can help me to learn, or if there is any problem, just correct me. That can help me to learn. If you don't like the video, I'm happy, but please leave the comments what you don't like the video, what you want more, so that I can help myself to improve it. Thank you, and see you in the next session. The next session we are going to start about individual layers in deep dive. What are the protocols, how those layers works with the communicates with the other layers. That's what we are going to look after the next session. Thank you. Tech and Shashi, presenting learning as a team. That is, please press the subscribe button and press the bell icon next to it so that you will be getting the notifications on the new technical videos.